Introduction to Architecture and Disaster Resilience. Architecture plays a crucial role in disaster resilience by designing structures and environments that can withstand, adapt to, and recover from various types of natural and man-made disasters. Effective architectural design enhances safety, reduces risk, and supports recovery efforts in the aftermath of disasters. Designing for structural integrity. One of the primary roles of architecture in disaster resilience is ensuring structural integrity. Buildings must be designed to withstand forces such as earthquakes, hurricanes, floods, and high winds. Techniques such as reinforced concrete, steel framing, and flexible foundations are used to enhance a building's ability to endure and recover from extreme conditions. Incorporating risk assessments. Architectural designs should incorporate risk assessments to address potential hazards specific to a region. This involves analyzing local environmental risks and adapting building practices accordingly. For example, flood-prone areas may require elevated structures, while regions prone to wildfires might benefit from fire-resistant materials and landscaping. Implementing adaptive design strategies. Adaptive design strategies enable buildings to adjust to changing conditions and future risks. Features such as adjustable flood barriers, retractable roofs, and modular components allow structures to adapt to varying environmental conditions and emerging threats. This flexibility is essential for enhancing long-term disaster resilience. Enhancing emergency preparedness. Architectural design contributes to disaster resilience by incorporating features that support emergency preparedness and response. This includes designing safe evacuation routes, emergency shelters, and resilient infrastructure for essential services such as water and electricity. Clear signage, accessible exits, and redundant systems improve the ability to respond effectively during emergencies. Promoting community resilience. Architecture supports community resilience by designing spaces that foster social cohesion and collective response. Community centers, public shelters, and multi-use spaces serve as hubs for disaster response and recovery, providing a gathering place for coordination and support. Well-planned public spaces enhance the community's ability to come together and recover after a disaster. Integrating sustainable practices. Sustainable architectural practices contribute to disaster resilience by minimizing environmental impact and enhancing resource efficiency. Green buildings with energy-efficient systems and sustainable materials are better equipped to withstand environmental stressors. Additionally, sustainable practices reduce the likelihood of exacerbating disaster conditions through pollution or resource depletion. Addressing building lifespan and maintenance. Long-term disaster resilience involves considering the lifespan and maintenance of buildings. Regular maintenance and updates to structural systems are essential for ensuring ongoing resilience. Architects must design buildings that are not only durable but also easy to maintain and upgrade as new technologies and materials become available. Collaborating with other disciplines. Architects collaborate with engineers, urban planners, and emergency management professionals to develop comprehensive disaster resilience strategies. This interdisciplinary approach ensures that architectural designs are integrated with broader disaster preparedness and response plans. Effective collaboration enhances the overall resilience of buildings and communities. Innovations in disaster-resilient architecture. Advancements in technology and materials are driving innovations in disaster-resilient architecture. Innovations such as earthquake-resistant isolators, hurricane-proof windows, and flood-resistant building materials are continually improving the ability of structures to withstand and recover from disasters. Embracing these innovations is crucial for advancing disaster resilience. Conclusion. Architecture plays a vital role in disaster resilience by ensuring structural integrity, incorporating risk assessments, and implementing adaptive strategies. By enhancing emergency preparedness, promoting community resilience, and integrating sustainable practices, architects contribute to safer and more resilient built environments. Collaborative efforts and ongoing innovation further strengthen the ability of buildings and communities to withstand and recover from disasters.